Welcome to the Chompman tutorial series. Based on the beloved classic arcade game Pac-Man, this project was created to be an easy-to-follow step-by-step guide that would give you the tools, techniques, and experience of creating a full game from start to finish. We've made all the original assets that we created for the game completely free. Links in the description below. For this project, if you wish to follow along step by step, you will need to first download the Chompman project files, both of which can be downloaded in the downloads area of the tutorial site or from links in the description.
In this Chompman Games Without Code boat video, we're going to continue developing our gameplay by creating our enemy AI. So the first thing that we want to do is we want to go to our Chompman folder and under our prefabs, and we're going to grab one of our ghosts. And we're going to place that into our scene. And now let's go to our graph. Now inside our graph, let's right click and let's create a new super state, and we're going to call that state movement. And we're going to set that state to toggle start. Now let's go inside of our movement state, and we're going to change this start state, and we're going to change that to chase. And now let's go inside of our chase state. So before we begin creating our states, let's first go over the logic that we want to create. So what we want to do is use the navigational mesh agent that we created when we set up our ghost to allow it to traverse our terrain and find and track our character. So to do this, we're going to use the nav mesh agent of our ghost variable, which it sets once our game begins. So we're going to grab our ghost variable, and then we want to create a get component node, and the component that we want to get is the nav mesh agent on that character. Next, we want to create a nav mesh agent set destination node, and the destination that we want to set is the position of our character. And for our input, we want to use our component from our nav mesh agent, and for our target, we want it to be our character. So for testing purposes, let's create a game object variable, and we're going to name that player, and we're going to move our player character in that game object variable. Next, we want to drag that variable into our graph, and we're going to use a get component node, and we're going to get the transform of that component, and then we're going to use a get position node, and we're going to plug that position into the target of our nav mesh agent set destination. So with that complete, if we were to test now, then we would see that the ghost really isn't moving, and we could see in our graph that everything seems to be working right. We have our player that's being found, and we have our state machines that all seem to be going into our navigational mesh. Everything is green, and we don't really have any errors. But before we want to use our navigational mesh agent, we first need to do two things. So the first thing that we need to do is we need to bake our navigational mesh. So to do this, we need to go to Windows, and under AI, you'll see navigation, and we're going to open that, which is going to open up a window. And so once we have our navigational window up, right now we're just going to dock this to a side window, and we want to go to our bake tab. And for Unity to be able to bake our navigational path, we need to first make sure the area that we want to bake is set on static. So let's go back into our maze, and we're just going to make sure that all of this is set to be on static. So we have all these as static meshes, as well as the children under them. So we're going to go back to our navigational window, and now we're going to hit bake, and we can see in these blue areas, this is the navigational path that Unity has baked for us. So we can see it's fairly thin. It has a fairly generous area away from our object. So let's adjust these numbers. So the main one we want to look is our agent radius. The higher that is set, the more area outside the object that it will include in your navigational mesh. For example, if we go and we're going to click bake, and we can see that the area is so thin now at this point that it's not really finding too many areas to bake. So let's go, and we're going to put that down to 0.2, and we can see now that we're getting a nice navigational area for the enemies to be able to roam yet not get too close to the walls. So let's go and see if we can make this a little bit tighter. We're going to go 0.15. And we really don't need to worry about our slope max and our step height, since much of our game is occurring on this flat plane. So the main thing we want to be focusing on is our agent radius. We want to make sure that our nav mesh is wide enough that the enemy is able to avoid the sides, yet tight enough that it's not cutting off any of our map area. So with that complete, let's go back into our flow graph. And the next thing that we want to do is we want to adjust our speed of our agent. So we're going to go to our navigational mesh, and we're going to see our navigational speed, which is 3.5. So we also, in between our getting our navigational mesh and setting our navigational destination, we need to set our navigational speed as well. We're going to create a navigational mesh set speed node, and we're going to plug our navigational mesh from our get component into our navigational mesh set speed node. And we want to create a new float scene variable, and we're going to name that variable ghost speed. And we're going to set the speed to 4.5 so the ghost moves slightly slower than the player. And let's hit play to test out our functionality. We can now see that the ghost seeks out after the player. If we move, we can see that the ghost can navigate the environment and is actively seeking out the player. With that complete, the next thing that we need to do is we need to have the scared state for our ghost, where the ghost will actually retreat from the player. So the first thing that we're going to do is we want to consolidate all of our ghosts into one macro. This way we won't have to constantly copy and paste any changes that we make from one macro to another macro. And instead of redoing this work, let's go and let's duplicate one of our macros. So we'll duplicate the one that we're currently using. We're currently using the red ghost. So whatever ghost that you're currently using. And before we do that, let's go and let's copy our variables and copy our states and make sure that they are in our prefab. So now let's go to our macro folder. And we're going to grab the red ghost, since that's the macro we've made all our adjustments to, and we're just going to duplicate this. And we're going to change this to ghost macro. So now let's place this, and we're just going to title this to ghost SM for a ghost state machine. So the first thing that we want to do is we want to create an object Boolean variable for each one of our ghosts. And after that, we also want to create game object variables and mesh render variables for each one of our ghosts also. So we're going to start with our Booleans, and we're going to name our first Boolean is blue ghost, is red ghost, is orange ghost, and is pink ghost. And for our game objects, we're going to call that ghost blue, ghost red, ghost orange, and ghost pink. And for our ghost mesh renders, we're going to call those ghost blue mesh render, ghost red mesh render, ghost orange mesh renderer, and ghost pink mesh renderer. So next we want to create a flow state, and we're going to call that picker. And from there, we're going to create a super state. And for this super state example, we're going to call this Ghost Red SS. And we're going to set our picker to toggle start. And we want to paste our blend shapes and our movement inside of our Ghost SS. And we're going to make a transition. And within this transition, we essentially want it to check our Boolean variables. So we're going to make a branch, and we want it to check our red ghost. And we're going to use an on enter state. Let's create another state, and let's separate the material generator from the blend shapes. So we're going to create another state, and we're going to call this material generator. And we're going to go into our start, and we're going to grab this first part where it generates our red material. And we're going to paste this within our material generator. And let's also create variables for each one of our materials. And we're going to name those variables Ghost Blue Material, Ghost Red Material, Ghost Orange Material, and Ghost Pink Material. And let's change our variables within this state. And we're going to change them to match our red ghost. So we're going to change our first object variable, and we're going to change that to our Ghost Red. And we're going to change this to our Ghost Red Material. And we're going to change this to our Ghost Red Mesh Renderer. And we want this to be toggle start also. Let's change this to blend shapes. And we're going to remove our start, and we're going to move our transition, and we're going to toggle start on our sheet up, and we're going to change this to our Ghost Red, and we're going to change this to our Ghost Red Mesh Renderer. So we're going to change that throughout all the states that we have within the super state. So let's go, and we're going to check our is red ghost, and then let's hit play to test that out and make sure that all of our functionality is still working. So we can now see we have our red ghost material that was created. If we go into our states, we can see that we have our blend shape fully functional, as well as our movement and our material generator, which created the red material. And if we can see that our ghost is finding our player, and all of our settings are still working correctly, and our Ghost Red Mesh Renderer is in its appropriate slot as well. So let's go into our Ghost Red Super State, and we're going to go into our Movement Super State, and let's create a new state, and we're going to call this Scared. And let's make a transition from our Chase to our Scared. And we're going to go in our transition. For our transition to happen, we want to use our is powered up Boolean. So we're going to say if our is powered up Boolean is true, we want it to transition to our is scared. And let's copy this, and we can create our transition back, which is essentially we're going to do the same thing, but we're going to do that on false. And so let's go into our scared state. And before we begin, what we want to do for our scared state is have a very similar logic than we have for our movement state, but instead of going towards the player, we want the ghost to actually run away from the player. So since a lot of the logic is going to be the same, what we can do is we can go into our chase state, and we're going to copy all these, and let's just paste them into our scared state. So in our scared state, the main difference that we're going to have is instead of our destination being towards the player, we're going to have our destination away from the player. So for that, we're going to use a subtract, and we're going to subtract the current ghost position from the player position. And we want to use a subtract vector 3 node. And we're going to put that as our new target destination. So let's go test that out. Before we do, let's go back into open our navigational window. And if we hit play, we'll notice that Unity is able to show us data from the character as we're in play mode. So we're going to unpause that and get our power pellet, and we could see that we have an issue now where a ghost is kind of stuck and not knowing what to do. So the quickest way to solve that is we need to make sure that our player is subtracting from our ghost, not the other way around. We go back into play mode. We can now see that we get that correct movement from the ghost, where it's trying to avoid the character. And once the power up is off, again the ghost goes back into that chase mode. If we go and we look at our graph, we can see that character transition from the scared to the chase and try to avoid the player. So lastly, we want to put in the actions that happen once the player has eaten the ghost or once the ghost has destroyed the player. So let's first go with once the player eats the ghost. So we're going to go into our chomp game object, and we're going to go into and let's change this from blink since we're using multiple state machines on here. And we're just going to rename this to chomp man state machine. So we're going to go under our player states. So we're going to go in our normal state. And on this normal state, the logic we want to do is we want to essentially say once the enemy trigger collides with the player trigger, if they're in this normal state, we want them to be destroyed. So to do that, what we're going to use is an on trigger enter. We want that to compare that with the tag of the enemy. And since we're just going to be using this in this one graph, we can just use a object variable, and we can make a enemy tag stream variable, and we're just going to tag that with enemy, which is the same tag that we use for our enemies. After we do that, we want it to go to a branch node, and we want that to compare that if that tag is true, if it's true that the enemy has come in contact with the player, we want that to then go to a destroy game object node. And the object that we want to destroy is self. Since we want to keep track of the amount of lives that the player has, instead of simply going to a player destroyed, we want to create a new variable that we're going to use. And we're going to make this a scene variable, and we're going to make this a boolean, and we're going to call this player was killed. This is going to activate one of our other states we're going to create in our next lesson that is essentially going to check how many lives that the player has left. Do they have another life left to continue, or has the player lost the game? So we're going to go to our scene variables, and we're going to create a boolean. We're going to call this player was killed. So we want to set this player was killed right before the object is destroyed. So before we move on to doing this for our ghost as well, let's test this out. So we can now see that our player is destroyed. If we go to our scene objects and go to our variables, we can see the player was killed, and the game object is no longer in our scene. So next we want to add the functionality when the player can actually destroy the ghost. So we're going to use a very similar logic than we're using for our player being destroyed. So let's go and we're going to copy these variables into our ghost as well. So before we do that, let's go and let's create, just to organize this, we're just going to group these together. And we're just going to copy these. And we're going to go into our ghosts and we're going to go into our movement and we're going to create a new state and we're going to plug this into the scared because that's the only point that the player can actually destroy the ghost. So we're going to create a new flow state. We're going to call that eaten. And we're going to make a transition from our scared to our eaten state. And let's go inside this transition. And inside this transition, let's paste our code that we copied from the chomp man. And so let's change our variable here from our enemy tag to our player tag. And since we have it in our scenes, we're going to go here. I'm just going to select our player tag. And instead of going to a destroy or setting that variable, I'm just going to remove these for now. And we're going to go to our state trigger transition. And from here, let's go and we're going to go to our eaten state. And in our eaten state, instead of destroying this game object, what we're going to do, since our ghosts are going to can come back and forth as many times as they want, we're just going to set this inactive and then we're going to reposition it in another state back into the ghost holding pin. So to do that, we want to get our ghost game object variable and then we want to have a game object set active variable. And we want to make sure that that value is unchecked. And to do that, we could just simply use a game object set active node and we can plug our ghost variable into our target. And we can just use the ghost variable as our target. And we can make sure that the value is unchecked to false. So we can now see that we have the AI for both our basic chase and the ghost retreating, as well as we have the ability to both consume the ghost and get destroyed by the ghost as well. So in the next lesson, we're going to continue developing our game mechanics and we're going to set up our life system as well as our respawn system for both our players and our ghost as well. So join us in the next lesson where we'll continue developing our gameplay for our Chomp Man games without code.
Don't forget to subscribe and hit that notification bell to be the first to see this and many other tutorials, game development tips, interviews, and free game asset giveaways.